This webinar deals with the subject of cover crop functions, and it's more of a general look, and another speaker will deal with in a separate webinar specifics for vegetable crop production in the Great Plains. So mine is a little bit more of an overview. And first, I thought I'd give the definition. This is the Soil Science Society of America definition of the purpose of a cover crop. It is a close-growing crop that provides soil protection, seeding protection, and soil improvement between periods of normal crop production, or between trees and orchards or vines and vineyards. When plowed under and incorporated into the soil, cover crops may be referred to as green manure crops. So, I'm going to go into a little more detail on some of those. So, as a soil scientist personally, I'm very interested in soil improvement and protection from erosion, and it's certainly possible, and I'll give some examples later. Cover crops can physically reduce compaction by building up soil structure over time, but also in the short term, just having roots present can give a soil a lot more strength. Weed control, I will show some details on that later. And cover crops are a great way to bring in some extra rotation, some extra crop rotation to help break disease and pest cycles for the cash crops, so such as nematodes and various other pests. And cover crops aid in cycling plant nutrients. For one thing, some crops are great at scavenging nutrients such as nitrogen. So in a sandy soil, some of the Brassicaceae species, for example, radishes, turnips, canola, kale, and so on. A lot of those are very good at scavenging nitrogen from deep depths as great as 8 or 9 feet before winter time. They can pull water and nutrients up and then hold those in the plant tissues until in the spring, when they decompose, nitrogen can be available for subsequent crops, and there's good research on that. Legumes clearly provide nitrogen, so that symbiotic relationship where they fix nitrogen, and that would be crucial in an organic system. Another important function of cover crops that's very specific to vegetable production is that some species require pollinators. And according to the the USDA National Ag Statistics Service, honeybees made 178 million pounds of honey in 2014, with the cost of honey at a record high then of about $2.16 per pound. That's a value of over $384 million for honey and beeswax. But the agricultural benefit of honeybees is estimated to be between 10 and 20 times the total value of that honey and beeswax. So in sum, they've calculated it to be about $15 billion in crop value is due to honeybees alone. And so it is a very important thing, and honeybees are certainly on the decline, and there's much research happening regarding that. So adding pollinators into a system at any point in the system would be a good thing. And this is just one example of a species that's very good at attracting pollinators. But really, when any of the species are flowering, it's a very, very good thing. So this is, clearly, this is in a vineyard system, but I was speaking with some winemakers and grape growers a couple months ago, and they're very interested in cover crops. So they would be very interested in planting cover crops between the rows for many of these different ecosystem services, and they're very open to grazing. So sheep are a very common part of some vineyards, and it's if you think also from a bit of the agritourism perspective, it's possibly something that could grow a little bit more. And then I would like to talk about evapotranspiration. So this is just a schematic showing that. So it is evaporation, which is coming from the soil, and it's transpiration, which is what's going through the plant. And so if we look at, this is from a recent experiment and cover crops and pumpkins. And so the cover crop was a cereal rye, which was roller crimped down and terminated. So in the spring, and then this is the irrigation tape that was placed out there, and then this is a pumpkin seedling, so it's being fertigated, so very little soil disturbance. And imagine what will happen in the heat of the summer. The radiation will come down, and a lot of that will be reflected instead of absorbed because this is light colored, and so there'll be a huge effect on reducing the evaporation. Instead, the water that's there can go towards transpiration, and also there would be a decrease in the amount of irrigation water required. This is a little bit later in the season. Again, you can kind of imagine the great decrease, and also it's very pleasant to walk upon this, and I'm sure it's cooler than walking on a dark soil surface. So now I'm going to tell you about some research that I've been involved in regarding cover crops, and this is in a cash crop system. So this is between wheat and sorghum, but the message is the same. And we're going to talk about soil improvement. So sun hemp, it's a summer legume, warm season legume, and we published this work. And so the idea, again, covers improved soil. And so we can raise soil organic matter in several different ways. So we can eliminate tillage, and this experiment is no-till. So it was a 15-year no-till experiment. Diversifying a crop rotation also can improve the soil organic matter. Adding more days when plants are growing. In other words, creating more biomass. So instead of just having soil microbes decomposing whatever biomass was produced or left over from the previous crop, now we're giving microbes some more material that they can ultimately decompose. So more crop biomass can equal more microbial biomass, and that's what's going to help with cycling nutrients and also in the production of organic matter. Adding nutrients, another strategy, and time. It takes time. Another fundamental sort of piece of information is that we can build soil organic matter faster for a soil that is finer textured. So I don't necessarily mean like 50% clay, but a soil that is a little bit, some clay and some silt, we can build that faster than a really sandy soil. And also, when I say wetter soils, I'm thinking eastern Kansas where there's more precipitation. It's easier to increase soil organic matter versus a drier place, maybe in southwestern Kansas, it would be slower. So I don't mean to be discouraging. I just want to frame this in a realistic way that there are things that and these can be additive. So we can adding cover crops or adding in more days when plants are growing and eliminating tillage can both add together. There can be synergy there. There can be even more. And again, these things happen differently in different places. So over to this graph. And so first I'll show you what's going on in terms of the bar color. So the black bars are for the 0 to 7.5 centimeter depth. Well, there's 2.5 centimeters in an inch. So this is 0 to 3 inch depth. And then the white bars are, this is 7.5 to 15 centimeters. So that's 3 to 6 inch depth. And then across the bottom it says no cover crop. Or late maturing soybeans, so that didn't set pods, that was just vegetative and then it was terminated. And then sun hemp. So these would have been planted after wheat. So after wheat is harvested, 1st of July or so, then these would have been planted and they would just grow, and then in the fall they'd be roller crimped down and also terminated with herbicide just to make sure they were good and dead. But the over here on the y-axis is soil organic carbon, and this is grams per kilogram. Well, in terms of percent, if I just put a decimal between the 2 and the 0, the 1 and the 7, and so on, this is the percent. So again, this one would be 1.7% organic carbon. Organic matter is about half organic carbon. So if I just do some quick math, these two, if I average them together, these two bars here would be about the same as 3.5% organic matter. And the little a's here mean that they're no different from each other. So these bars are about 3.5% organic matter. And this one here, so if 1.4 times 2, that'd be about 2.8% organic matter. So no-till, these are all a no-till experiment. And I don't know what the organic matter was before we started the experiment. It was before my time, but I know that by managing it the same, and the only thing that's different is the addition of cover crop, we increased that 0.7, 0.8% organic matter. So that's quite a bit. That's a pretty good amount of change over time. So that's great. Change organic matter. So what? Well, it's the what is affected by organic matter that's really, really exciting. So in this case, this is infiltration, and this is cumulative water infiltration. So we pounded rings in the ground, and then we watched the water move in over a period of 180 minutes or 3 hours. So how much water soaked in the ground? So ignore those top two bars for a second. Just look at this lower line. So would you be happy with 2 inches of water ponded moving into your soil in 3 hours? I certainly would. That's pretty good. And then with the addition of the cover crops, that increased dramatically. So by the end of that 3 hour period for the soybean, about 4 inches soaked in, and by the end of that 3 hour period for sun hemp, about 6 inches soaked in. So again, this is related to this: more organic matter, more infiltration. And that's because there was better aggregation. The soil organic matter took the sand, silt, and clay particles, stuck them together very well, and created nice, strong aggregates. And then there's also an earthworm effect. So this is the same treatments again. This is the amount of earthworms in a cubic yard. So the units are kind of silly, but the point is the same. Sun hemp had a lot more than the soybeans. The soybeans had a lot more than the cover crop. So you can see it's sort of chicken and egg. Which caused what? So there was a lot of earthworms. Did that cause the infiltration? Probably. And probably goes back to the organic matter. All three are consistently related to each other. What's cool about the earthworms is this. So I was out there digging these up in December 2009 in green sorghum stalks. So if you think about that for a second, that year, that growing season of 2009, there was green sorghum growing there. So you have to look into 2008. Imagine yourself in 2008. That was when the cover crops were last there. So the wheat was harvested in like about July 1st of 2008, and then cover crops were planted, and then they died, and in 2009 the sorghum was planted. The point is, it had been about 13 to 14 months since sun hemp was even growing in this area, and still that's where the worms preferred to be. And these no cover crop plots, they were all scattered around. This is the average of three different plots, 3 or 4 different plots to get this number. And so it was markedly different. They preferred to be here. So earthworms preferred to be here, and they probably caused, so the earthworms preferred to be where the sun hemp plots, which probably also created the infiltration. And again, so these things, they all go together. Okay, so a little bit more on earthworms and why they're really great for soils. They stimulate microbial activity, and that's because they consume microbes as they're moving through soil. They're consuming everything in front of them. They're consuming soil, but they're also consuming organic, material, so like roots or maybe some above ground plant parts if they're the kind that comes up to the surface. And then also there are microbes present in their gut just like us, and so the earthworm casts are full of microorganisms, and they fragmented the old plant parts that were there. And then also scientists have taken and measured the amount of nitrogen, phosphorus, and potassium that are in the earthworm casts, and that is higher amounts. There's higher available nutrients, like plant available nutrients there than in the soil itself. So they're cycling that even faster. Now I'm going to show you a little bit of earthworm data that I collected in 2015. I haven't published this yet, but it's in a corn-soybean cover crop experiment at Ottawa, Kansas, so kind of eastern Kansas, and it was collected in April 2015 prior to soybean planted. And that's about a perfect time to go find earthworms. The soil was nice and moist, wasn't too warm yet. It's a great time to go look for earthworms when the soil is about 50 degrees Fahrenheit or less. So when we say that's about corn planting temperature too. So it was perfect time to go do it. And we dug up a cubic foot of soil, dug a big square out of the ground, stuck it in a 5-gallon bucket, and then took and separated that all out. Like within the few days, you had to do that measurement to make sure that they didn't die. And so these are just the different treatments. So I'll start at the bottom with no cover. Obviously no cover. And the weeds were controlled very well, so there was nothing growing. And radish was the treatment, rye was the treatment, and we mixed rye and radish together. And then we had one with rye, radish, and alfalfa. And then the 7-way mix was rye, radish, and alfalfa, and then turnip and paja, and wheat, and sorghum on top of that. And statistically, these were not different from each other. This project's been going on a few years, not 15, but under 5 or so. So perhaps after 10 years, there might be more sorting, more differences among treatment, but so far they're not statistically different. So 10 is a bit of a threshold. We say if you've got more than 10 earthworms in a cubic foot of soil, that's fantastic. The soil is very, very healthy. 1 to 10 would be pretty good, or 1 to 9 would be pretty good, and 0 would be a bad sign. So no matter what the treatments were, we had at least 6 point something, the no cover, and some of these other treatments, however. So let's talk about weeds. Shifting gears. This is an experiment, and it's the caption says near complete suppression of weeds in April. And I didn't take this credit or didn't take this photo. The author of this particular agronomy journal paper did. And so the title is called "Forage Radish Cover Crop Suppresses Winter Annual Weeds in Fall and Before Corn Planting." And so their ultimate conclusion was that if, there's some ifs here, if planted in a timely manner, forage radishes might be able to be used in place of a pre-plant burn down herbicide for early planted corn. And we've observed this a few times, but this is definitely something that has to be scouted. You can't just assume anything. You would have to scout that and be very sure. And this is, you might think, why? Well, clearly there's nothing growing there. It's not like there's a bunch of cereal rye physically suppressing it. Like cereal rye does that because of sunlight. It's blocking sunlight from hitting those from the seeds that are laying there. In this case, it's more of a chemical/biological process that's preventing the winter annual weeds, such as for us that would be henbit in Kansas, from growing. So that would have to be scouted, but it's a good potential one. Another weed that does a great job, or another cover crop that does a great job suppressing weeds, is buckwheat. And buckwheat is a cool crop because it takes 45 days to grow from planting it to maturity, which is just super fast, and it's a good one to use in summer. And if you had a problematic weed, you could use buckwheat and plant it at a really thick, really high rate, and use that to suppress weeds. So that was kind of a special situation, but that's called a smother crop, and it's a really, really good one for that. So now, shifting gears again, let's talk about legume cover crops. So these are just a few examples. Crimson clover and hairy vegetables would be planted in the fall, terminated in the spring. And sun hemp, cowpeas, and soybeans, those would be summer. So it just depends on which one would work for you and what you're growing. But these are the potential nitrogen fixation ranges. So it all depends on how early you get it established and how well it grows. So it can be a huge range. And then the available nitrogen in pounds per acre ends up being about half. So if you only get 60 fixed from crimson clover, you'll get about 30 available that next year. And the remainder of that, so if we get 50%, the remainder of that nitrogen may be available to plants at some other point, or it may go into building soil organic matter. So I said soil organic matter is about half carbon. Well, it's also got a large component of nitrogen as well. So, but it will kind of feed the soil and feed the system. So some of this is, about half is available for the subsequent crop, and half is going to be going into the system somewhere, potentially feeding the soil. So I'm coming to the part of the presentation, coming to the end, where I'm going to talk about resources. And this is one that was written a few years ago, but it's still completely relevant. All the same plants that we talk about planting now were in this publication. So Cover Crops for Vegetable Growers, and it's an excellent resource still available online at the K-State Extension bookstore. And also, a very exciting development is that Kansas has joined the Midwest Cover Crops Council about 2 years ago, and now we are our information is about ready to go live. By the time you listen to this, it'll be going live as far as the online decision tool. And so you put in your location, your cash crop, and you tell it what objectives you have. And I'm going to give you a quick demonstration of that. Now, I will say it's not we didn't fill out the information for vegetable crops. We've only done it for cash crops, but many of they're similar in terms of which cover crops are used in either production, cash crops or vegetable crops. In fact, I know many vegetable producers actually rotate vegetables with cash crops. So the information is still going to be very useful. It's just not quite as fine-tuned for vegetable producers as we might like. So I'm going to click over, show you my screen. And so it's actually going to be on this page, but the main page has a bunch of resources. So we will select our state as Kansas. I'm going to select Sedgwick County, which is where the John C. Parr Horticultural Center is and where I've studied pumpkins and cover crops. And so, okay, first thing, put in our cash crop. And so I'll just roll down. You can see that these are all the choices. And since I haven't made any decisions yet, none of these have dropped out. But watch what happens if I pick, let's pick soybeans as my cover crop, or as my cash crop. Let's say I'm going to plant those in Sedgwick County April 25th, and I'm going to harvest them, let's say September 16th. Well, that puts in the growing season, and that, obviously it's going to drop all those choices out. So now the green are the dates at which things could be reliably planted. And the yellow basically says freeze risk to establishment, which I would say is pretty much a waste of money for the seeds. So then drainage class, we can put in moderately well drained. This probably doesn't change too many things. And flooding, I'll ignore that. So goal, now we can select an attribute. So let's say nitrogen source. If we do that, it grays out all of everything but a legume. And so now if we focus in on the legumes, like hairy vetch is a 4 and guar is a 2. So 4 would be better than a 2. But, that it you'd probably definitely look at the cool season ones for sure. So, yeah, so soybeans really wouldn't work. They wouldn't, work at the same time, but and sun hemp wouldn't work at all either. But crimson clover, red clover, and some of the different the cool seasons would work. And so instead of nitrogen source, let's say soil builder. Well, that's going to bring back many of these things that produce high amounts of biomass. They're back up here. So, and then let's say I want to select a second attribute, and let's say I want lasting residue. I'm going to guess that many of those non-legumes are still going to be there. And so you can see how now it's kind of taken and created two. So it's kind of bringing those together. So, but there's a lot less options for sure. There's less things that are still on the table, and so that'd be like winter barley, cereal rye, annual ryegrass, spring triticale, some of those. So I think you've gotten the picture there with the tool and how it's going to work, and so that'll be hopefully useful to many people. And with that, that concludes this presentation on the functions of cover crops and the general function of cover crops.